Hi, in this video, I'll show you how to use recursion to solve this problem. Check if a word is a palindrome. So what is a palindrome? A palindrome, you read the same backward as forward. What does it mean? So we have in here, for example, this word A and A, if we read it from backward, then this A and A, and the same as read it from forward. So this one is the palindrome. So the output is true. Second one, race car. Right? R-A-C-E-C-A-R. So you see R-A-C-E-C-A-R. So they are the same. When we read backward, it's forward. So this is true again. The last one, a test. So T-E-S-T. And backwards is T-S-E-T, and this is different, right? And because of that, the output is false. How can we solve this problem? So let's start with the method, right? Status method. We return a boolean. We check if this one is a palindrome, and the output, the input is a word. Okay, so let's start. How can we solve this problem recursively? So let's go back, right? In recursive, again, in our some of the last video, we say that computer can always solve the problem automatically. And the problem here is the problem with lesser input. So let's say, let's look at this one, right? Let's look at this error. If the computer helper to check a subproblem with lesser input, can we solve this? For example, if the computer can solve this problem, for example, can say N is not a palindrome. Can we solve the problem with 8? So there's not many meaning, right? A and N is not a palindrome, and after that with A, not so much meaning, right? It's the same for here. If we break the problem from A, and then after that, N and A in here. So in here, N and A is not a palindrome, do not show anything if we add 8 at the beginning. So this kind of breaking problem, we cannot solve the problem. However, if we look at it, right, how about this? If we break the problem that somehow computer can always solve the subproblem automatically, and the subproblem is that the same word without the first and the last character. Can we check if the whole thing is a palindrome? Again, let's say that the computer can return us that NN is already a palindrome. Can we check if this word A and A is a palindrome or not? So the answer is yes. How? We check the first character and the last character. If they are the same, and provided that this one has been solved by the computer, then we can solve the whole problem. What is if the given word is the palindrome or not? This is the idea. The same thing in here. For example, this gray car. Again, we know that computer can solve the problem for here already. A-C-E-C-A. So this one, the computer said this is a palindrome, A-C-E-C-A. And the return is true. Then our job is just check the first and the last character. If it is still true, if the first and the last character is okay, the same, then the whole word will be palindrome. So this is the idea. Okay? How we can implement it? Again, let's go. All right, so we say that computer has already solved for subword or substring. I have the substring in here, right? Substring. And this substring is the original word without the first. So we start with the second character. So the first character, this is second character. We start with second and we stop at except the last character. So this should be the word length minus 2. So we know that computer has already solved this problem. So I have Boolean is substring palindrome. So this one has already solved by the computer is palindrome. So this one already solved by the computer. So if this one is not a palindrome, of course the whole word is not a palindrome. Yeah, so if is substring not a palindrome, then of course the whole word is not a palindrome. However, if the substring is a palindrome, then what we do, we need to check if the first character, check if the first and the last character is the same. So we need to check that if the first character equal to the last character. Yes, this is the one. Word length minus 1. If they're the same, then the whole thing is a palindrome. Else, then it's not. The whole thing is not a palindrome. We solved the problem already. Okay, so this is a typo. We're done. Okay, so we're done with the first step. We solved the whole problem. We know that the computer can help us to solve the subproblem automatically. And now we solve the whole problem. So this is the first step. Now we need to go to the second step. We need to find the base case. What does it mean by the base case? In here. So in this algorithm, we know that, we need to get the substring, right? And the substring is get the first one. All right, so this is the substring. And now the next round is get the first one and the last one. So this is substring. And the next round is put the first and the last one. So finally, we will have something that only one character. And if this one only has one character, of course, this is a palindrome, right? So this means that if the word length is 1, then of course we can return true. So this is one scenario. Right? Another scenario is that, for example, Anna here. Again, we strip out the first one and the last one. We have NN. And later we have N, we strip out the first one and the last one. So finally we have an empty string in here. It means that if the empty string, then we can return true as well. Empty string in this situation is a palindrome. So the second base case is if the word length equal to 0, then of course this is a palindrome. We're done. So what we do, right? We do 2 steps, right? The first one is we know that computer can help us to solve the subproblem automatically. So this is the one, and we choose the subproblem is the substring without the first and the last character. And after that, we say that computer has already helped us to solve this problem. If the computer helped us already, then if the result of the substring is not a palindrome, of course the total one is not. If the result is a palindrome, right? So this one else, if the result is a palindrome, then we need to further check if the first character is the same as the last character. So it's the one. If yes, then return true, is palindrome. If not, then it's not. The total is not. So this is the first step. The second step, we need to find the base cases. So we say that, our recursion, we strip out the first one and the first character and the last character. So it's slowly like at the beginning, right? So for example, race car, we strip the first and the last, it's become this string. Now we strip the first and the last, it's become this string. After that, we strip the first and the last, so it's become this string. And this string is only one character. And one character we can stop already. We can stop that the method has the subtask that don't need to call itself anymore, but can decide already, can perform already. And this situation can decide that E is a palindrome. But this is only one situation. The second situation is that, for example, here we strip the first character and the last character, first character and the last character, and finally we'll have this empty string. Empty string, also palindrome. We done everything already. So now let's test our program. So I test Anna, race, cars, and test. You see? Let's run. This is the thing. The first one is true, Anna. The second is true, race car, and the last one is false, which is test. So this is how we apply the recursive method to solve our problem to check if a word is a palindrome. Alright, so and of course after solving the problem, now we can do refactor to clean up the code. For example, this is two condition, right? So we can combine them together because two condition, only one type return. Both return true. One thing. Next one is which one? If some condition, then return true, otherwise return false. So actually just return this condition is enough. Right. And of course, you know that this is the parameter, isn't it? Right. So we can put this whole chunk, replace this parameter, because this parameter substring is only used one. And this one we can, again, what we do, we can replace everything for this parameter. So this is the simpler version, right? And later, if you even make it simpler, right, we want to increase the efficiency, we can check the word first before checking the palindrome, and everything can be combined only this one line of code. So they're still the same. So I check this word first, and after that I check this palindrome of the substring later. So actually, this is the simplest version, right? The shortcut version, not the simplest one, the shortcut version. So if we run, they still the same, true, true, and false. I hope you enjoyed the video, and thank you very much.